This is the Edexcel November 2021 Foundation Tier Calculator paper. Question 1 says write 45% as a decimal. To change a percentage into a decimal, we divide by 100. So 45 divided by 100 is 0.45. But the calculator will do this for you. So if you type in the calculator 45 and then percent, which is shift then ANS, 45%, press equals. It changed it to a fraction first, and then press the S to D button, and it says 0.45. That's 45% as a decimal. Question 2. Write down two factors of 35. So the factors of 35 are the numbers that multiply together to make 35. So we can have 1 times 35. It's not in the 2 times table, or the 3 times table, or the 4 times table, but it's 5 times 7. So the factors of 35 are 1, 5, 7, and 35. We only need to write down 2 of them. So we can write down 1 and 5, or any 2 of them. Question 3. What is the time 2 hours 40 minutes after 8:05 a.m.? So it's 8:05. We want to add on 2 hours. So if we add on 2 hours, it will be 10:05 a.m. And then if we add on 40 minutes, 40 minutes after 10:05 will be 10:45 a.m. So that's 10:45 a.m. The calculator will do this as well. So if we start with 8:05, that's 8 hours and 5 minutes. And we add on 2 hours and 40 minutes, we should get 10:45. Question 4. Work out 1/6 of 66. So without the calculator, to find a sixth of something, we divide by 6. So 66 divided by 6 is 11. So 1/6 of 66 is 11. But with the calculator, of means times. So it's 1/6 times 66. Type it in the calculator. 1/6 of 66 is 11. Question 5. AB is a straight line marked with across the midpoint of AB. So we need to find the middle of this line. So we can use our ruler. If we measure the length of A to B, so I've got 7.4 centimeters. You might have something slightly different on your piece of paper. So 7.4, half of that is 3.7. So we want to go 3.7 centimeters across. That's to there. That's to there. So we'll mark a cross there. And that will be our answer. Question 6. Simplify A times B times 4. So in algebra, we don't write the times sign. We just write everything together. So A times B times 4, we can just write, we put the number first, 4AB. So 4AB. That means 4 times A times B, but we don't write the times sign. So I've just moved the number to the front and just written 4AB. Part B, simplify. 4x plus 3 minus x plus 5. So we can add up the x's we've got 4x, and we've got take away x minus x. We always use the sign from in front of the term. For the numbers, we've got positive 3 and a positive 5, so 3 plus 5. So 4x take away 1x is 3x, and 3 and 5 added together make a positive 8. So 3x plus 8. Question 7. Here are 3 cards. No, there are 3 cards in bag A and 2 cards in bag B. There is a letter on each card. James takes a card from bag A and a card from bag B. List all the possible outcomes. So we could get an E from A, and then J from B, or we could also get E and K. They're all the options with E. Now G, G and J, and G and K, and finally F, F and J, and F and K. They are all the options. Question 8. On Monday, Sandy pays for 2 plane tickets, 7 nights in a hotel, and 2 theme park tickets. Show that Sandy pays more than $2,500 on Monday. So 2 plane tickets, that's 2 600s. 7 nights in a hotel, that's 7 120s. And 2 theme park tickets, that's 2 250s. So 2 600s, 2 times 6 is 12, so add on the 2 zeros. 2 25s are 50, and add on the 0, so 2 times 250 is 500, and 7 times 120 is 840. So what is the total? 1,200 plus 840 plus 500. Add them all together, we get 2,540. So that's more than 2,500. Question 9. Vadim has 56 clocks. The clocks are only red, only blue, or only black. 32 of the clocks are plastic. So we're going to complete this two-way table. Vadim has 56 clocks, so that's going to be the total. 32 plastic, so the total of the plastic is 32. I won't fill in the other ones yet, I'll just fill in the information we're given. 5 of the 14 blue clocks are plastic. So there are 14 blue clocks, 5 are plastic. And 8 of the 12 red clocks are not plastic. Complete the two-way table. So we'll fill in the missing information now. So 56 take away 32 will tell us the number of not plastic clocks. 56 take away 32 is 24. 56 take away 12 and take away 14 will tell us the number of black clocks. 56 minus 12 minus 14 is 30. We could get the number of plastic red clocks. 12 take away 8 is 4. And the number of not plastic blue clocks. So 5 and 9 make 14. So now we've got 17. Well, we can just use the calculator. So for plastic, 32 take away 5 and take away 4 is 23. So we should be left with 7 here. We can just check 8, 9 and 7 make 24. They do. So it adds up in both directions. So it must be correct. Question 10. Karina has £300 to spend on books. Each book costs £4.85. Work out the greatest number of books Karina can buy. So how many £4.85s go into 300? So we can divide 300 divided by £4.85. 300 divided by £4.85 is 61.8 and so on. So how many can she buy? She can't buy 61.8 books. So she doesn't have enough to buy 62. It must be 61. 61 is the greatest number of £4.85s that go into 300. Question 11. Write 196 minutes in hours and minutes. So we could count up in 60s. So we could say 60 is 1 hour. 120 is 2 hours. 180 is 3 hours. And then how many more minutes do we have? 196 take away 180 will be 16. So 16 more minutes. We could have also divided by 60. So we could have said 196 divided by 60 and typed it in the calculator. And we get 3.26, which isn't very useful, but we can press this time button and it will say 3 hours, 16 minutes. A train travels X miles in 2 hours. Write down an expression in terms of X for the average speed of the train. So if we can go X miles in 2 hours, how far can we go in 1 hour? Because we're measuring speed in miles per hour. So how many miles can we go in an hour? So we have to half it. So what's half of X? Well, we could write half X, or X over 2 miles in 1 hour. So what's the speed in miles per hour? Half X, or X over 2. That's how many miles we go in an hour. Question 12. The diagram shows 2 places on the map. We've got Shelton and Trilby. The scale says 1 centimetre represents 20 kilometres. What is the actual distance in kilometres from Shelton to Trilby? So we need to measure with a ruler the distance and then use the scale. 1 centimetre is 20 kilometres. So how many centimetres is it? So we'll get the ruler. And we have 2.5 centimetres. So we've got 2.5 centimetres. Every centimetre is 20 kilometres. So 2.5 times 20. 2.5 times 20 gives us 50 kilometres. So every centimetre is 20 kilometres. So 2.5 centimetres is 50 kilometres. On a scale drawing, a different one, the scale is given as 1 to 1,200. How many meters does 5 centimetres represent on this drawing? So 5 centimetres times 1,200 will be 6,000. So that's 6,000, but it's 6,000 centimetres, not meters. So 100 centimetres make a metre. So 6,000 centimetres divided by 100 is 60 metres. So to change from centimetres to metres, divide by 100. 6,000 divided by 100 is 60. Question 13. In the northern hemisphere, the ratio of the area of land to the area of water is 2 to 3. Work out what percentage of the area of the northern hemisphere is land. So land to water is 2 to 3. So what fraction is land? So there's 2 parts that are land. Out of 2 plus 3, 5 parts in total. So 2/5 is land. What's that as a percentage? To change it to a percentage, times by 100. So 2/5 times 100, or 2/5 of 100, is 40%. %20 of the area of the southern hemisphere is land. Work out the ratio of the area of land to the area of water in the southern hemisphere. So land to water, it's 20% land, which must mean the rest, which is 80, because percentages are out of 100, 80% must be water. So it's 20 to 80. It didn't ask us to simplify, but I will anyway. So divide them both by 20 is 1 to 4. So the ratio is 1 to 4. Question 14. A stadium costs 600 million. 13/15 of this cost was for the building. The rest of the cost was for the land. Work out the cost of the land. So we've got 2 ways of doing this. We could work out the cost of the building first. So 13/15 of, so times 600 million. So 13/15 of 600 is 520. So it cost 520 million for the building. The rest was for the land. So 600 million minus 520 million is 80 million. So 80 million. The other way of doing it, we could have said if 13/15 is for the building, everything else is for the land, that's 2/15. So 13/15 and 2/15 add up to 1 whole. So we could have done 2/15 of 600 million, which would have given us 80 million. So that's an alternative. Either way, we're going to end up with 80 million. Jenna measures all the angles around a point. Her results are 23, 145, 23, and 69. Explain why these results cannot be true. So 23, 145, 23, and 69 make 260 degrees. So I'll write that down. Equals 260 degrees. Angles around a point should add up to 360 degrees. So angles around a point add to 360 degrees, not 260 degrees. Question 16. Here is a diagram showing triangle ABC and triangle ADE. Fully describe the single transformation that maps triangle ABC, the little one, onto triangle ADE, which is the big one. So because the triangle is changed size, it's got bigger or smaller, in this case bigger, we call that an enlargement. Enlargement. What's the scale factor? So triangle ABC is 1 along the bottom. Triangle ADE is 1, 2, 3, 4. So to go from 1 to 4, you times by 4. So the scale factor is 4. So we've got enlargement, scale factor. One more piece of information we need to know, and that's the center of enlargement. So I'll write center, and where's the enlargement coming from? So I'm going to join up the points of a straight line and see where they meet. So B and D go together, E and C go together, and you can see A hasn't moved. So the center of enlargement, because A hasn't moved, it must be at A. So it's at 1, 1. The center is at 1, 1. Question 17, expand. So expand means get rid of the brackets, multiply out the brackets. So we times the thing outside by both of the things inside. Y times y is y squared, and then y times 5 is 5y. And they're added together, so it's plus 5y. Factorize, part B. Factorize means put back into brackets. So we have 4a minus 6. What is in both of 4a and 6? What can I take out of 4a and 6? I can take 2 out of them. 4 and 6 are both in the 2 times table. So I have 2 on the outside. 2 times something makes 4a. 2 times 2a makes 4a. The sign's a minus. I'm just going to write the minus sign there. 2 times something makes 6. 2 times 3 makes 6. So if I expanded these brackets, I would go back to 4a minus 6. Expanding and factorizing are the opposites of each other. Part C. Solve. So 2 times 4x minus 4 equals 21. So I'll start by expanding the bracket. So timesing the thing outside by both of the things inside. 2 times 5x is 10x. 2 times negative 4 is negative 8. And that equals 21. So now I'm solving the equation. I want to know what x is. I need to get x by itself. So I'm going to get rid of this minus 8 first. And to get rid of it, I do the opposite of minus 8, which is adding 8. So I add 8 to both sides of the equal sign. So minus 8 plus 8 is nothing. That gets rid of it. So I've just got 10x left on the left. And I've got 21 plus 8, which is 29 on the right. So 10x equals 29. I want x by itself. At the moment, it's multiplied by 10. So I want to do the opposite of multiplying by 10, and that's dividing by 10. So divide both sides by 10. X is 2.9. And part D, simplify. 4e squared f times 5e f cubed. So 4e squared f actually means 4 times e squared times f, and then times 5 times e times f cubed. So what we're going to do, we're going to multiply together the things that we can. So the two numbers, 4 and 5, we can times them together and get 20. E squared means e times e. We're multiplying it by another e. That's going to give us e cubed. E times e times e. And f times f times f times f. 4 f's will be f to the power of 4. Question 18. Change 1 meter squared into centimeters squared. So if we've got a meter squared, that means it's 1 meter, a square, 1 meter by 1 meter. In centimeters, each meter is 100 centimeters. So how many centimeter squareds make 1 meter squared? Well, 100 centimeters along, 100 centimeters up means 100 times 100 which is 10,000 centimeters squared. So 10,000 little centimeter squares can fit into 1 meter squared. Question 19. This diagram shows two squares. So we've got a square inside a square. Work out the area of the square shown shaded in the diagram. So we don't know the lengths of the square shaded, but we can use Pythagoras to work them out, because we've got a right angle triangle here. So this is a right angle triangle. If we want to know a missing length of a right angle triangle, and we know the other two lengths, we can use Pythagoras. So Pythagoras' theorem says a squared plus b squared equals c squared. The two short sides squared and added together equal the long side squared. So if this is x, I can say 3 squared plus 5 squared equals x squared. So I'm going to write 3 squared plus 5 squared in my calculator, and I get 34. So x squared is 34. So I could work out what the length is by square rooting it, but actually that's what I want to know. I want to know what x squared is, because the length of each length of this square is x, so I'm working out x times x, which is x squared. So that's what I'm working out. So it's 34. So we're not given the units, so it's centimeters squared. So what I could have done is I could have square rooted my answer and said each length is 5.83, but then I would have done 5.83 times 5.83, which is answer times answer, and that goes back to 34. So the answer is 34 centimeters squared. Question 20. Here are the heights in centimeters of 15 plants, and we need to draw a stem and leaf diagram for their heights. So for a stem and leaf diagram, we split in this case, the tens from the ones. So we're going to have the tens. So the tens, that's 20, 30, and I can't see a 40. I don't think there is one. So then we start filling them in. I'm going to start from the zeros on the ones. So that's 20. There are no more zeros. There are no ones. There's 22. 32, 22 again. Any more twos? Nope, any threes, so 33. There are no more threes there, so on to the fours, 24. And that's it. The fives, we've got 15, 25, 35, and 25 again. And sixes, there are none. Sevens, 17. And then the eights, we've got 18 and 28. And then two 19s for the nines. And that is all of the numbers crossed off. We can check there are 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15. And we need to fill out the key. So 1, 5, 1 with a line then 5, means 15 centimeters. And that is our stem and leaf diagram. Question 21. The scatter graph shows information about the volume of traffic and the carbon monoxide level at a point on a road each day for 22 days. One point is an outlier. Write down the coordinates of this point. So which point doesn't fit the trend? Which point is out by itself? That's this point over here at 118. For another day, 370 cars passed the point on the road. Estimate the carbon monoxide level for this day. So to use a scatter graph to estimate a point, we need to draw a line of best fit. So it's a line that best fits the relationship. So we're going roughly through the middle of all these points with roughly the same amount on both sides, kind of minimizing the distance from the points to the line. So something like this. So look at how many I've got on both sides. So I've got maybe 10 on both sides there. There's more than 10. So now I've got 10 on each side and 1 on the middle. That works. So somewhere around there, we'll have a line of best fit, something like that. So everyone's line will be slightly different, but as long as it fits the relationship, then it will be okay. And we are estimating 370 cars. So we're going to do a line from 370 goes up to our line of best fit and then along. So I've got 14 milligrams per meter cubed. Alfie says because there is an outlier, there is no correlation. Is Alfie correct? So no, Alfie's not correct because we were still able to draw a line of best fit. So no, we were still able to draw a line of best fit. So just that one point doesn't fit the correlation. That doesn't mean there's no correlation for the rest of the points. Question 22. Natalie makes potato cakes in a restaurant. She mixes potato, cheese and onion so that the weight of potato to the weight of cheese to the weight of onion is 9 to 2 to 1. She needs to make 6,000 grams of potato cakes, and cheese costs £2.25 for 175 grams. Work out the cost of the cheese needed to make 6,000 grams of potato cakes. So we've got 9, 2 and 1. So that's 9 parts, 2 parts to 1 part. So I could draw 9 boxes, 2 boxes and 1 box. So I will do that. So I'm going to draw 9 boxes. Two boxes and 1 box. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 to 2 to 1. So I've got 9 to 2 to 1. That means I've got 12 boxes in total. So I'm dividing 6,000 equally between these 12 boxes. So 6,000 divided by 12 is 500. So each box is worth 500. I'm only interested in the cheese though. So there are 2 boxes of cheese. That's 1,000 grams of cheese. The question isn't quite clear here whether we can buy as much cheese as we want, if we can buy 1,000 grams of cheese exactly, or if we have to buy them in 175 gram blocks. So we could come up with 2 answers here. Either one would be marked correct. So if we said we had to buy exactly 1,000 grams, we'd say 175 grams will cost £2.25. Then if I divide by 175 and find 1 gram, or divide by 7 and get 25 grams, I'll do that. So 175 divided by 7 is 25. So if I divide by 7, I can find the cost of 25 grams. So £2.25 divided by 7 is 32.14 and so on p. So then I need to times by 4 to get 100 grams, or 40 to get 1,000 grams. So times by 40, and that will be, so this is in p, so 1,286p, or £12.86. Now, if I had assumed that I can only buy them in 175 gram blocks, so how many would I need? 175. How many blocks do I need if I did? I need 1,000 grams, don't I? So 1,000 divided by 175 is 5.7 and so on. So I need 6 lots. So I need 6. I can't buy 5.7. If I'm assuming I can't buy 5.7 amounts, I'd buy 6 lots of £2.25. And that will cost me £13.50. So either one of those 2 answers. So if we're assuming we can buy 1,000 grams of cheese exactly, I've got £12.86. If I'm assuming that I can only buy them in 175 gram blocks, I've got £13.50. Either are correct. Question 23. Write 4.5 times 10 to the power of 5 as an ordinary number. So if I type it in the calculator, 4.5 times 10 to the power of 5, it converts it for me. So it's 450,000. 4.5 times 10, 5 times. So 450,000. Write 0.007 in standard form. So let's try it again. So 0.007, and it's got 7 times 10 to the power of -3. So how can I get from 0.007 to something in standard form? I have to divide by 10 1, 2, 3 times. So that's 7 times 10 to the power of -3, divided by 7 3 times. Work out 4.2 times 10 to the power of 3 plus 5.3 times 10 to the power of 2. Give your answer in standard form. So let's use the calculator. 4.2 times 10 to the power of 3 plus 5.3 times 10 to the power of 2. So I've got 4,730. That's not in standard form. So I need a number between 1 and 10. That's going to be 4.73 times 10 to a power. So if I had 4.73, I'll have to times by 10 1, 2, 3 times to get 4,730. I can check my answer by typing in the calculator 4.73 times 10 to the power of 3, and it gives me 4,730. Question 24. A water tank is empty. Anil needs to fill the water tank with 2,400 litres of water. Company A supplies water at a rate of 8 litres in 1 minute 40 seconds. Company B supplies water at a rate of 2.2 gallons per minute. 1 gallon is 4.54 litres. Company A would take more time to fill up the tank than Company B would. How much more time? So let's do Company A first. So 8 litres in 1 minute and 40 seconds. So that's 60 seconds and 40 seconds. So that's 100 seconds. So 8 litres in 100 seconds. We need 2,400 litres. So what do we have to multiply by? 2,400 divided by 8 is 300. So if we times by 300, we will get 2,400 litres in 300 times 100, so 30,000 seconds. And I can change that into minutes. So 100 times 300, 30,000 seconds, divide it by 60, and that's 500 minutes. So 500 minutes. So that's Company A. Now we need to do Company B. How long did Company B take? So 2.2 gallons per minute. 2.2 gallons per minute. So each gallon is 4.54 litres. So to get 2.2 gallons, we need to times by 2.2. So 2.2 times 4.54 is 9.988. So it's 9.988 litres. So we've got 9.988 litres per minute. So we need to get to 2,400 litres. What do we need to multiply by? So what do we need to multiply by? So what do I times 9.988 by to get to 2,400? To get that, I'll get 2,400 divided by 9.988, which is 240.28, and so on. So if we multiply a minute, 1 minute times 240 will be 240 minutes. So how much quicker is it? So we've got 500 and we've got 240. So we'll take them away. So that's 260. 260 minutes. Question 25. The first four terms of a Fibonacci sequence are A, 2A, 3A, and 5A. So in a Fibonacci sequence, we're going to add the first two terms to get the third term, and then add the second and the third term to get the fourth term, and then we'll add the third and fourth to get the fifth, and then the fourth and fifth to get the sixth, and so on. The sum of the first five terms of the sequence, so these terms, 1, 2, 3, 4, 5, is 228. Work out the value of A. So A plus 2A plus 3A plus 5A plus 8A is 228. So how many A's do we have? So 1, 2, 3, and then 6, 11, 19. So 19 A's are 228. We could have, of course, used a calculator here. So 1A plus 2A plus 3A plus 5A plus 8A will be 19A. So 19A is 228. To get A by itself, divide both sides by 19. So 228 divided by 19 is 12. So A is 12. Question 26. In a bag there are only red counters, blue counters, green counters, and pink counters. A counter is going to be taken at random from the bag. The table shows the probabilities of taking a red counter or a blue counter. The probability of getting a green is 0.2 more than a pink. So if X is pink, green is X plus 0.2. We need to complete the table. So all probabilities, everything that can happen, must add up to 1. So we've got 0.05, 0.15 plus X plus 0.2 plus X must equal 1 whole. So if we add up our numbers, 0.05, 0.15, and 0.2, that's 2/5 or 0.4, plus X and X, so 2X equals 1. So take 0.4 off of both sides, so 2X equals 0.6, and then half both sides, X is 0.3. So the probability of pink is 0.3, green is X plus 0.2, so 0.3 plus 0.2, 0.5. There are 18 blue counters in the bag. Work out the total number of counters in the bag. So 0.15 of the total, so times the total, I'll write T, 0.15 times T equals 18. 15% of the total is 18. So what is the total? Well, we could divide both sides by 0.15. So 18 divided by 0.15 is 120. We could have also said 15% of the total is 18. Divide by 3 and get 5% is 6. Then you could double it for 10%. And then times by 10 for 100%. So 120 counters. Question 27. The diagram shows a sector OPQR of a circle, center O, radius 8. OPR is a triangle. Work out the area of the shaded segment PQR. Give your answer. Correct the 3 significant figures. So here we have a quarter of a circle and a triangle. So the shaded segment is the area of the quarter circle. Take away the area of the triangle. So the area of the quarter circle will be pi r squared divided by 4. A quarter of pi r squared. And the radius is 8, so it's pi times 8 squared divided by 4. So pi times 8 squared divided by 4 is 16 pi. I think I'll leave it as 16 pi for now. If you did change it to a decimal, that's 50.265 and so on. The area of the triangle is half times base times height. 8 times 8 divided by 2, or half times 8 times 8. So 8 times 8 is 64. Half of that is 32. So that's 32. So the segment is the area of the semicircle. Take away the area of the triangle. So 16 pi, take away 32. 16 pi minus 32 is 18.3. So 18.3 centimeters squared. And question 28. Sketch the graph of y equals 1 over x, 1 divided by x. So this is a reciprocal graph. It cannot equal 0, and you cannot divide by 0. So it never touches the y-axis, and it never touches the x-axis. So if you put in a really, really small number, a decimal, a tiny decimal, you'll get a massive answer out. So it starts off really high on the y-axis, and the bigger number you put in, the smaller the answer. So it kind of makes a curve round like that. And if you put in a negative x, you get out a negative answer. So it makes another curve down like that. So that is our graph of y equals 1 over x.